Yay, now I can record. All right, so this is sums and difference formulas. And if you are taking notes, go ahead and take out your notebook. This is 5.2 class discussion. And we are going to talk a little bit about this stuff. We have a bell ringer today, which will apply to some of the things you did later. You will do later. So this is your bell ringer. It says find the values of X and Y in terms of alpha, right? So go ahead and draw your picture and write the statement because you're going to need it for later. Hi, Bianca. 5.2 is due Sunday night. Okay, so it's due Sunday night. If you haven't read the posts on Google Classroom, go back and read them. All our assignments are going to be due on Sunday night. And assume that they are assigned Monday morning. So 5.2 will be due this Sunday night. 5.3 will be due next Sunday night, next week, and so on. All right, hopefully you got your pictures, right? And let's see if we can go ahead and take a look at this. It says find the values of X and Y in terms of alpha. So this is our good friend, old Indian chief, Soka, Hoa, right? So what is, and again, if you want to participate, just leave your microphone on. And if I start getting weird feedback, that's happened to me a couple of times already, I'll just go ahead and mute you. Nothing personal. I'll just mute everybody. And then as you start participating, just unmute yourself. Don't take it personal because it's just a button that says mute everybody. And it's just a quicker way to get everybody muted. If I start getting the weird feedback, I think my internet's running really well today. I'm surprised. I don't even want to say it. All right. So you remember old Indian chief, Noah, right? So what is Y in terms of alpha? Which one are we using? This is the side that is what to alpha? Y is the side that is what to alpha?
Opposite.
Opposite.
And we know that the hypotenuse is going to be what?
1.
1.
1, right? So, okay. And Britannia and others. So now I can find what Y is, right? In terms of alpha. What's it going to be? Y is going to equal?
1 over 1?
Well, it would be what? Sine of alpha is equal to opposite over
Y over 1.
1, right? Is that true? So it's just what? Sine of?
Y.
Sine of Y? No. Sine of?
Alpha equals Y.
Boy, we're rusty. We are rusty. My computer's not working so well. Here we go. All right. So Y equals sine of alpha. Everybody okay with that or no?
Yeah.
Yes.
Okay. So what is X going to equal?
Cosine of alpha?
Good job. Don't know who that was, but good job.
Mr. Check like the participants.
Thank you. And good for letting me know there were 2 there. Who knows how long they've been there? Poor thing. All right. So X is equal to cosine of alpha. Everybody okay with that?
Yeah.
Yeah? Okay. Let's try this one now. Find the values of X and Y in terms of alpha and R. So notice our hypotenuse was 1 before, now it's R.
Okay.
Okay. And You guys have like a little window with my mohawk looking thing looking back at you?
Yeah.
I think I'll take that off so then that way you guys can see the whole presentation. Where is that thing? There we go. Is that better? No, you still see it, right? No, it's just something else. That little window won't go away, will it?
No.
All right. I think I'm better looking than Batman with the mask. All right, so let's see. We got an idea? So what's y in this case?
Sine is gonna A over R, alpha over R.
Okay, remember that sine of alpha would be what?
Y.
Y over
1.
R, right? Sine of alpha. This is not working. See, there goes my computer. I can read it. Sine of alpha would be y over r, right?
Yeah.
So I multiply both sides by r to solve for y. When I multiply both sides by r, what do I get?
R sine of alpha equals y.
There you go. R sine of alpha equals y. Everybody okay with that?
Yeah.
Okay. See, my computer was working like a rock star a second ago, and now it's just back to what it did yesterday. But we'll see what it does. So what would x be in that case?
R
Cosine
cosine
of
of
X.
alpha.
There you go. Good job. Okay. R cosine alpha.
R cos.
Okay. R cosine alpha. Got the idea?
Yeah.
All right. So for this section, this is what we are going to do. Our objectives. Use a formula for cosine of a difference of two angles. Use the sum and difference formulas for cosine and sines, and use the sum and difference formulas for tangents. We're also going to take a look at an informal proof of one of these sum formulas. So then that way you kind of see where it comes from, and they can all be proved similarly, and we're not doing an actual proof, we're doing a similar proof. So we'll see what that is, okay? So let's start off here. You may not want to write it in English, but you definitely want to copy this formula. The cosine of the difference of two angles. So it says the cosine of the difference of two angles is equal to
Cosine times alpha.
cosine of alpha, good Yusef. Okay, cosine of alpha, which is our first angle, right? Alpha represents our first angle, times
Cosine of beta.
cosine of beta, good Talia, which is our second angle, right? So times the cosine of the second angle, plus what?
Sine of alpha.
Sine of alpha, good. Somebody took notes. I like it. Somebody, sine of alpha, which is our first angle, times what?
Sine of beta.
Sine of beta.
Sine of beta, right? So a lot of you took notes, apparently. I saw Priscilla and Talia and a lot of people asking. So let's take a look here. So go ahead and write that formula down. In case you don't have it already. And we are going to apply it, see how this plays out. So we know that. So this is example one. So write example one using the difference formula for cosines to find an exact value. So how do we find an exact value? We know that the cosine of 30 degrees is what? Anybody remember? I'll give you a hint.
Radical 3 over 2.
Radical 3 over 2. Good evenings. In case you forgot, that's why we made that table, right? You're going to see how the table and the unit circle start to play a part now in everything you do. So you're better off memorizing those values. And even the unit circle, the one that you learned with Ms. Coronel, once we got to that point, that has the quadrantal angles, is probably the better one to remember, because I remember she taught you a little trick about cosine to remember the quadrantal angles, the 0, 1, 1, 0, and all that stuff.
Mm-hmm.
And we'll talk about it today, in case you forgot that, right? So this is a square root of 3 over 2. So what do they want us to do? They want us to obtain this exact value by using the difference formula of cosine. So this is kind of an informal proof, an algebraic proof of that fact, that the cosine of 30 degrees is the same as the cosine of the quantity 90 minus 60 degrees. Okay, so how do we do that? Well, we know that's true, right? Cosine of 30 degrees is equal to the cosine of 90 minus 30 degrees. And according to what we just wrote down, the difference formula for cosines, the cosine of the quantity alpha minus beta is what? Anybody?
Cosine of alpha times the cosine of beta.
Good. Go ahead.
Plus sine of alpha times the sine of beta.
Very good. Was the sine of beta, right? So that means what's my alpha here?
90.
90. And what is my beta?
60.
60. So I'm just rewriting this in terms of alpha, beta being 90 and 60, right? So I'm just going to rewrite that in terms of alpha and beta, right? Go ahead and write it down, right? So that's cosine of 90 times cosine of 60 plus sine of 90 times sine of 60. And again, these are formulas that you're going to memorize. They're going to come up a lot next year.
You should make a study sheet, Mr. Delgado.
Yes, you can. Are you volunteering?
I have one.
You have one? Cool. Post it on Classroom. Take a pic and post it on Classroom. People would love that.
Okay.
Mr. Delgado, check the participants.
Thank you. Appreciate it. That was another one. Way to go, Batania. All right, so we got that. So now, this is what I was talking about, right, for the next step. If my computer wants to work, maybe it does, maybe it doesn't, okay. So this is what I was saying, that graphic. Okay, so take a picture with a screenshot or write it down. Notice it has the quadrantal angles, and that's what Ms. Coronel taught you about co and sine, right? In parentheses, so you know what the coordinates are, right? The advantage to this graphic is the fact that you have them. If you remember, we had all students take calculus, right? To remember which ones are positive and negative and in which quadrants. So the advantage to this one is that you already have the values and they have a positive and a negative on them. And instead of angles, you can replace the angles with radians also, okay? All right, so for this one, the first one is one of those quadrantal angles, cosine of 90, right? So what's cosine of 90? Cosine of 90 would be? What's the cosine of 90, Priscilla?
1.
Cosine of 90 is 1?
0.
0, right? It's 0, right? Cosine of 90 is 0. Think back to the graphic, right? Cosine of 90 would be up here, right? Cosine of 90 and cosine is the first one. So it would be 0. And now cosine of 60.
1/2.
1/2. Very good, right? Whether you use a table or you use that graph. Good job, you said. Okay.
Okay.
And then now sine of 90.
1.
Sine of 90 is 1. Good evenings. Okay, sine of 90 is 1, right? And then sine of 60.
Square root of 3 over 2.
There you go. Square root of 3 over 2, right? And from here, the rest is just multiplying and arithmetic, right? Basic stuff. 0 times anything is 0. And then 1 times the square root of 3 over 2 is going to be square root of 3 over 2. We good? Yes, no, maybe so?
Is there a certain order that you had to multiply it? Like PEMDAS?
Yeah. Order of operations applies here. So you have to do the multiplications first, right? So then you end up with 0 plus the square root of 3 over 2, and 0 plus anything is whatever that other stuff is. So,
All right.
yeah. Good point. Always PEMDAS. All right, we're good. Ready? Example 2. It says find the exact value of cosine of 70 times cosine of 40 plus sine of 70 times sine of 40. Wants to find the exact value. Go ahead and copy it down. So we're still using the difference formula of cosine. All right. So let's see. We've got this. Cosine of 70 times cosine of 40 plus sine of 70 times sine of 40. Well, if the cosine of alpha minus beta is equal to what?
30.
The formula.
Oh, sorry. Cosine of A minus B equals cosine alpha cosine times cosine beta plus sine of alpha times sine of beta.
Very good. Then the other way around must be true also, right? That means I can flip these two around and you have the same thing, right? So now, just as Yusuf said earlier, I can just apply this, except that my alpha is going to be what?
70.
Good. So alpha 70, beta is 40. And then now I can just subtract the 2, and I end up with cosine of 30. And cosine of 30 is what? Cosine of 30 is?
Square root of 3 over 2.
Square root of 3 over 2. Okay, whether you use a table or you use the unit circle. Okay. Good with that one? Yes, no, maybe so?
Wait, hold on.
You said no, Yusuf?
So what happens? So what happens to the sine of 30?
So what happens to the sine of 30? Remember, it's not sine, it's cosine. We had cosine, right?
Yeah.
So this is a formula for cosine of alpha minus beta, right?
Okay. Yeah.
If it were a sine of alpha minus beta, it'd be something different, right?
Okay.
The cosine of 30 is square root of 3 over 2. You okay with that? Did I answer your question?
Yeah.
Okay. All right. Example 2. So now it's verifying this identity. We have to verify this identity. Which side looks tougher, the left or the right?
The left.
The left, right? The left definitely looks tougher, right? Neither one looks easy, but remember, whenever we're trying to verify, we always start with the more challenging side, right? So we're going to start off with the left. So this is, we got to verify this identity and seeing how we end up on the other side, right? So we start off with cosine of the quantity alpha minus beta over cosine alpha times cosine beta. So let's see, cosine of alpha minus beta. What's cosine of alpha minus beta? Well, we had that earlier, right?
Cosine of alpha times cosine of beta plus sine of alpha times sine of beta.
Very good, right? So that's what it is. So now I'm going to replace that, right? And put that as my numerator. And now I can go ahead and split these two fractions apart, right? So on the left side, I'm going to end up with,
What if you just multiply the denominator? Wait, never mind. Forget that.
there are many ways to do this, Yusuf, and you'll learn, you'll start to see. They did it a certain way. Like, for example, when I've solved these problems myself, independent of the book, I got to the same answer and I did it differently sometimes. So there's
All right.
more than one way to do this. The more you know, the less steps you have to take. But if you don't notice something sometimes, then you'll take more steps. You'll still end up at the right place, but it may take you a few more steps or a few less steps, depending on how you saw it. So there's not only one way to do this. This is just one way.
Okay.
And that'll happen a lot, especially with this stuff, okay? There's more than one way. So notice what they did here is they split it apart, right? So what's going to happen to the first term, the cosine alpha, cosine beta over cosine alpha, cosine beta?
It cancels out.
Right, that becomes a
1.
1, right? That becomes a 1, right? And then the other side, I still have sine alpha, sine beta over cosine alpha, cosine beta, right?
Yeah.
So what do I know about that? Everybody okay with this step? I can move on. That becomes a 1. And then I can split these two apart, right? I can split these two apart as sine alpha over cosine alpha to sine beta over cosine beta. And what is sine alpha over cosine alpha?
Tangent alpha.
Tan alpha, right? Tan alpha. Good job. Okay. Tan alpha. And what is sine beta over cosine beta?
Tangent beta.
Tangent beta, right? Tangent of beta, right? So I can replace those for sine alpha over cosine alpha and sine beta over cosine beta, right? Which is what I was trying to do in order to verify the identity, right? Because I ended up with the right side of the equation, right? So the identity is verified. We good, Jess? No, maybe so?
So the answer is 1 plus tangent alpha times tangent beta.
Correct, because the idea was to verify the identity. What they wanted us to do was verify the identity. So they will give you something like this, Yusuf, where they want you to prove, and this is an algebraic proof, right? But this book is calling it verify the identity. In Algebra 1 and Algebra 2, they called it an algebraic proof. So you're
All right.
verifying the identity. You're making sure that this is equal to this, because they don't look the same. So when somebody looks at it, they go, what? That's not the same thing. They look totally different. Well, you can get algebraically, you can prove that one is equal to the other.
Okay.
Okay. We press on. Everybody good so far? I'm hearing a couple of people. I haven't been checking my chat. So if you're, I don't get any messages either. Okay, so this is the sum and difference formulas for sines and cosines. And these are 4 of them, right? 1, cosine of the quantity alpha plus beta is equal to cosine alpha cosine beta minus sine alpha times sine beta. Numero 2. My computer is on slow-mo. I swear I clicked. Oh, wow. See? I clicked. Cosine of the quantity alpha minus beta is equal to cosine alpha times cosine beta plus sine alpha times sine beta. And I know some of you have these in your notes already, which is great. Always, always read and take notes before you come to class because it'll make more sense to you then. The next one is sine alpha plus beta is equal to sine alpha times cosine beta plus cosine alpha times sine beta. Okay, and the last one, sine alpha minus beta is equal to sine alpha times cosine beta minus cosine alpha times sine beta. And the answer, Nicole, is no. You do not get graded on participation. I just enjoy hearing your voices. I'm sorry to hear that you have no voice, but that's okay. I'll try to monitor the chat. You can keep chatting if you have a question, and I'll try to monitor the chat. Remember, these are for you guys to learn. You just have to attend 1 for the marking period to get credit, but I encourage you, it is highly recommended that you guys attend these sessions because it'll clear up some things for you as we go through these lessons, okay? Like I said, School Yourself, if you haven't been there yet, they have this section in School Yourself is excellent, and it's most of chapter 5. So if you want to go to School Yourself and do those lessons on your own, then it'll help you quite a bit. And yes, test grades are going in this marking period. We'll talk about that towards the end. I'm going to do just a regular grading like I normally do, and at the very end, we'll have a couple of sessions where we're going to talk about what we're going to do with grading, okay? Thank you, Evans. Appreciate it. All right, that's enough time. So we're going to take a look at this one. It's going to be an informal proof, but we'll take a look at it and see what we how we get from one to the other, because that sounds strange, right? How do you get from sine of the quantity alpha plus beta to equal sine of alpha times cosine beta plus cosine alpha times sine beta? So how do you get from one to the other? So let's take a look at that, okay? So you don't have to draw these if you would like. I'm going to give you a little bit of time to draw them, so then that way you can see them. So you would draw a right triangle like this, right? And call that angle alpha. And then you're going to draw on top of this one another right triangle, right? And you're going to make that angle beta. So an angle that looks like this, and make that one beta. Make sure you make the right angle at the right place. Okay, and now we're going to start to find some of the legs lengths on these triangles. And then you're going to go, oh, that's why we did the bell ringer. So first thing is this side over here, right? Oh, we'll make that length 1. Sorry, I forgot about that. That length is 1. So first is this side over here. What would be the length of that side over there if that hypotenuse for B is 1? I heard it. Somebody's trying to whisper it. I heard you, Yusuf. Say it like you mean it.
I'm thinking like if it's sine of B, it's gonna be hypotenuse.
There you go, sine of B. That's it, sine of B. Look at your bell ringer. It's the same picture, right?
Yeah.
Because instead of an alpha, you have a B. So
Yeah.
this side would be sine of B, right? So what's this side over here going to be?
Cosine of B.
Good, Talia. That's cosine of B, right? That's cosine of B. Everybody okay with that? Now be careful on the next one. Be careful on the next one, because this one is the hypotenuse length is no longer going to be 1, right? So what's this one going to be over here?
Sine of A.
No.
You're close. It's sine of A times, Talia said no. She called you out. No.
Cosine B.
And come from side B.
There you go. Good, Jasenia. Sine A cosine B, right? Sine A cosine B, right? Because my hypotenuse is cosine B. So what's this side over here going to be?
Cosine A, cosine B.
Cosine B.
Good. Good, Jasenia and Talia. Good job, right? Everybody okay with that? I love that. It looks so cool and it works out so nicely. Makes me so happy. All right, so now up here, we're going to draw a triangle, okay? Up here, we're going to draw another triangle. Like so. Okay, so I'll give you a few seconds to draw that one. It's another right triangle, right? And the first thing we need is to find out what this angle is here. What's going to be the length of that angle there? I'm sorry, the measure of that angle there. Not the length.
Sine of B is the hypotenuse.
Any guesses?
Sine of B.
Yes. I think so too. So no ideas? Well, let's see. This one is 90 degrees, right? This one here is 90 degrees.
Yeah.
And what would this angle be over here? Well, I know this one's 90, so this one has to be 90 because they have to be complementary, right?
So 180, yeah.
Minus A, right? That one's 90 minus A, right? With me so far? Everybody with me so far? Yay, nay?
Yeah.
Yeah?
Yeah.
So now I know that from, let me see if I can switch colors here. From here to here, and somebody mentioned it, I think it was you, Seb, is how many degrees?
180.
180, right? So if I rewrite this, that means that 90 minus A plus 90, right? That's the next one, plus that question mark, right? Plus question mark has to give me 180, right? So that's what I'm solving. So go ahead and solve that. What would you get?
Whatever A is also whatever the question mark is.
So if I move A to the other side, I've got 180 plus A, right? Plus A is equal to 180 plus a question mark, right?
Yeah.
180 plus the question mark, right? What happens to the 180s?
Cancel out.
They cancel each other out, right? So I end up with the question mark, right?
Yeah.
So that angle happens to be, that angle is going to be,
45 degrees.
well, not 40, we don't 45 degrees. If A was 45, that would be true, but I know it's definitely equal to A, right? Agreed?
Yeah. So sine of A.
So it's, well, you'd think it's sine of A, right? I would jumped all over that one for this side up here, right? But it's not. It's not sine of A. What is it going to be? What's the hypotenuse in that little triangle?
Sine of B.
Sine of B. So that side over there has to be what?
Cosine of A times sine of B.
Good, Talia. Sine of A times sine of B, right? Everybody okay with that one?
Yeah, let me draw it real quick.
And then now the other side, this side over here. What's this side over here going to be?
Cosine of A.
Cosine of A times sine of B.
Good. Good, Yesenia and Talia. Good job. Cosine of A, sine of B, right? Now the last thing, because this picture's gotten kind of busy, right? But those are the lengths of the side. So now we're going to drop a line right from where it says sine of A, sine of B, all the way down, a perpendicular line. And we're going to take a look at a new triangle here, right? With this length here, right? Which is going to be the same length as that side over there, right? So if we just take a look at that piece right there, what's the length of that side? Is it going to be cosine of A plus B, sine of A plus B, or tangent of A plus B?
Sine of A. Wait, hold on. Sine of A plus B.
Very good. Sine of A plus B. And not just because we said that's the one we were going to talk about, but because if you take a look at this angle here, right? This angle here is the sum of those two angles, A and B, right? That's the sum of those two angles. And for this triangle, the big triangle here, that side represents the side that is opposite angle A plus B, right? So if it's opposite and hypotenuse that we need, notice the hypotenuse is still 1, it would be sine of AB, right? So now if we take that length there, right? And we see that that length is the same as the other side, right? Now we can see that this is sine of A plus B. And now we can see where the formula comes from, right? Sine of A plus B is sine of A plus B is
Times cosine of beta plus sine. Beta times, cosine of alpha.
there you go. That's it, right? See it?
Yeah.
And a similar proof can be done for all of the other ones, right? A similar proof can be done for all of the other ones. We're just not going to do the proofs. We're going to trust that the math will work out, and it does. You like that? I thought that was so much fun. Some people sound sleepy. How many people thought it was fun?
That's bad.
Even my daughter over here is going, She doesn't think it's that much fun. She thinks her daddy's a nerd. She's calling me a nerd, but her idea of movie night is to watch a documentary. So just to let you know. All right, moving on. Let's take a look at a problem. So they want us to find the exact value of the sine of 5 pi over 12 using the fact that 5 pi over 12 is equal to pi over 6 plus pi over 4. Go ahead, and this is example 3. Everybody good?
Yeah.
Yeah, okay. So let's take a look. Well, the sine of 5 pi over 12 is the same thing as the sine of the sum of those two terms, right?
Yeah.
So what we just saw what the sine of alpha plus beta is, right? Sine of alpha plus beta is equal to?
Sine of alpha plus sine of alpha times sine of beta plus
Not
sine of beta times sine of alpha.
Sine of alpha times
Oh,
cosine beta
plus sine of beta times cosine alpha.
There you go. Sine of beta cosine alpha. Got it?
Yeah.
All right. So now I need to split those two apart, right? So I got sine of
Pi over 6
pi over 6 times what?
plus cosine of pi over 4
Cosine of pi over 4. Come on, buddy.
plus cosine of pi over 6
Good.
plus sine of pi over 4.
Cosine of pi over 4. Good job. Way to go, Yusuf. All right. And now I need to go ahead and figure out what these are, right? Whether you're using the table or the unit circle. I'll put the table up here. Sine of pi over 6, which is what?
1/2.
1/2. So now I'm going to replace that for sine of pi over 6. And I do the same thing with the other ones. Cosine of pi over 4. That's the next one, right? Cosine of pi over 4 is?
So pi is square root of 2 over 2.
Square root of 2 over 2. So I'm going to replace that. And then we have cosine of pi over 6.
Square root of 3 over 2.
That's the square root of 3 over 2. So I'm going to replace that. And the last one, sine of pi over 4.
Square root of 2 over 2.
Square root of 2 over 2. And the rest is the multiplying fractions, applying your rules for radicals, and combining your fractions together. So 1 times the square root of 2 over 2 times 2, that was going to give me a square root of 2 over 4, plus square root of 3 times the square root of 2 is what?
Radical 6.
Square root of 6 over?
4.
And then I go ahead and simplify, right? They're both over 4, so I can just write it as one fraction. You good? Yes, no, maybe so?
Yeah.
Okie dokie. We move on. Now for the next few examples, they're going to have those two lines at the top. They're going to continue to put that. So the problem is really find the exact value of cosine of alpha. So if you want to write that statement up top, it applies to the next few problems. It says, suppose that sine of alpha equals 4 over 5 for quadrant 2 angle alpha, and sine of beta is equal to 1/2 for a quadrant 1 angle beta. Okay? So here they're talking about the cosine of alpha. So if they're talking about the cosine of alpha, which statement am I interested in? The one on the top line or the second line? Which one is talking about the angle alpha? The top one's talking about the angle alpha, right? So I need this
Yeah.
statement up here, right? I need this statement up here. So a quick review on what we talked about earlier, right? If we have our Cartesian coordinate plane, right? You remember that we had all students take calculus, right? All students take calculus. That means all trig functions are positive in the first quadrant, only sine in the second one, only tangent in the third, and only cosine in the fourth. Correct? So now they're saying the sine of alpha, so it's going to be it's a quadrant 2 angle alpha, so that's why it's positive, right? So here is our sine of alpha. Here's alpha, right? That's our angle alpha. Our reference angle is going to be on the other side of that, right? Our reference angle is right in there. See it? So now we have X, Y, and R, right? X, Y, and R, right? So in terms of our reference angle, right? Sine of alpha should be what? Remember where our reference angle is. I should have put it on here, but I didn't. I'll just draw it in, hopefully. Our reference angle is here, right? So what's sine of alpha going to be? Sine is what? Opposite over
Hypotenuse.
hypotenuse, right? So what's the opposite that angle? Opposite is
Y over R.
y over r. Good, just saying y over r, right? So it's going to be y over r. Y over r, right? And they told us that was what? Right from the beginning, they told us that this was
Oh, 4 over 5.
4 over 5. Good. Okay, so that is 4 over 5. All I'm missing now is x, right? All I'm missing now is x. But remember, that's a right triangle, isn't it? So what can I use to figure out what x is?
Pythagorean theorem.
Good job, Talia. Pythagorean theorem or Pythagorean theorem, whichever way you want to say it, right? So now I'm going to do x squared plus y squared equals r squared. And substitute your values. X is what we're looking for. What is y? Y
4.
is 4, good. And what is r?
5.
R is 5, right? So I substitute my values, and then I solve. 4 squared is 16, 5 squared is 25, and then I subtract. I get that x squared is equal to 9. Take the square root of both sides. I guess that x equals what?
3.
Plus or minus 3, right? But in this case, we are going that way, right? We're going to the left, to the left. So that means it should be what?
Negative.
Very good, negative. Good, Anthony, good to send it. Should be negative, okay? So it's x is negative 3. So my answer is negative 3, right?
No.
No, good, Talia. Somebody fell for it yesterday. They said, yeah, right. So it's not negative 3. Why? Because I wasn't asked to find x. I was asked to find what?
Cosine alpha.
Cosine alpha. Good, Anthony, right? So what would be the cosine of alpha? Cosine of alpha is what? In terms of x, y, and r, it would be what?
X over R.
X over r. Very good. It would be x over r, right? So x is
Negative 3 over 5.
negative 3 over 5. Very good, which makes it negative 3/5. Is that the idea? Yes, no, maybe so?
Yes.
Good. All right, we ready? I'm going to let you guys try the next one. We'll do the next one together-ish, and then I'll let you do that. I think there's 3 of these, so we'll try it. Yeah, there's 3 of these. So in this one, they want us to find the exact value of cosine of beta. Cosine of beta. You guys want to give it a go, and then I'll meet back up with you? Yeah, okay. So I'll let you guys work on this one. I got several people that want to try this one. So try this one. I'll give you 2 minutes. Okay? Go to work. Okay, let's go over it and see how you guys did. All right, so cosine of beta. So we need the second part of the statement now, right? So it's in quadrant 1, so we know it's that part of it is positive. And now that is my angle beta. In terms of x, y, and r, what is sine of beta?
Y over R.
Y over r. Very good. Y over r. Good, Musa. Good, Anthony. Okay. So now, what's y in this case?
1.
1,
1. Good, Musa. Right. And what's r?
2,
2. Right. 1 over 2. That's y over r. Right. And now what can I do to figure out what x is?
Pythagorean theorem.
Pythagorean theorem. Good, just saying. So Pythagorean theorem that, right? Substitute your values. Y is 1, R is 2, and then I'm solving for x. 1 squared is 1, 2 squared is 4, subtract the 1, and I get that x is going to equal
Square root of 3.
Got it? By the way, guys, if you need to leave to go to another class or you just got it from there, you got what you needed, you can always go just send me a message on the chat because I take a picture at the end of class to give you credit for the marking period. So I don't want to deny you credit. So if you have to go, just let me know that you're leaving on the chat. And then that way I can look it back in case there's a question on whether you attended a chat or not. All right, so we got the square root of 3. So my answer is the square root of 3, correct? Correct?
Yeah.
No, why not?
No,
I need to find what?
You have to
the
do over
cosine
R.
of b.
All right.
So it'd be the square root of 3 over 2.
Okay. So now I need to find the cosine. I need to find the cosine now of B. Cosine of B is what in terms of X, Y, and R?
X over R.
X over R. Good, Daniel. X over R, so that's going to be what?
Square root of 3 over 2.
Square root of 3 over 2. Good, Roberto. Good, Jasenia. Okay. Got it? Make sense? Like I told you, none of this stuff is hard. It's just new, right? This is stuff that you're learning some new bits and applying them. Not that big a deal. Oops. Those of you who are leaving, see you later. Example 6. So this is, suppose you have to find the exact value of cosine of alpha plus beta. So now we need both of these, right?
Yeah.
Now we need both of these. And we're going to use some of the information that we already came across, right? So let's see. We have sine of alpha, sine of beta, cosine alpha, cosine beta. What was sine of alpha?
4 over 5.
4 over 5. And sine of beta?
1 1/2.
1/2. Very good, right? And then what is cosine alpha?
-3 over 5.
-3 over 5. And cosine beta?
Square root of 3 over 2.
Square root of 3 over 2. So now let's put this together. Cosine of alpha minus beta. What was cosine of alpha minus beta? It is, I'm sorry, cosine of alpha plus beta.
Cosine of alpha times sine of beta.
Times sine of beta. I'm sorry, not cosine alpha times
Cosine beta minus sine alpha times sine beta.
There we go. That's right. We good?
Yeah.
And now we're just plugging in values, right? Because we have them. Cosine alpha is -3 over 5. Oops. See, my computer's on super lag now. -3 over 5, that's cosine alpha. Cosine beta is?
Square root of 3 over 2.
Right. Square root of 3 over 2. Good job, Anthony and Jasenia. And then?
4 over 5 times 1/2.
4
Well,
over
negative
5 times 1/2. Good, Jason, right? 4 over 5 times 1/2. And the rest here is just combining fractions, multiplying, simple stuff, right? So that's going to be -3 square root of 3 over 10 minus 4 over 10. And then you can combine both since they have the same denominator. Got it, just no, maybe so?
Yeah.
All right, we'll move on.
Wait, mister.
Yeah.
Can you show what the answer was on the last one, real quick?
There you go.
Thank you, sir.
Mhm. Now notice it's the same statement up top, but now they want you to find the exact value of sine of alpha plus beta, right? So I'll give you a minute or two to try to work that out on your own. Again, remember where you started, right? You've already done the work. You don't need to do all that work again. You've already got those, right? So just put in those values in there. You should have them from the previous problem. So you can just probably start working on sine of alpha plus beta. So the key thing here is to remember those formulas for sums and differences of sines and cosines. Once you commit those to memory, then everything else should be pretty easy. The rest of the stuff you should know. All right, we're good. Need another minute? Okay. So this is what we had already from sine and cosine of alpha and beta. So now it's just a matter of putting in your values into the formula. All right, those of you who need to go to another class, no problem. See you guys later. This will be recorded, so if you want to watch the end later on, you can, okay? Sorry it took a little longer than it should have. It's just I wanted to get you guys to see the proof. All right, so this is, from here, it's just substituting your values. You apply the formula, and then you substitute your values. So sine of alpha is 4/5. Cosine of beta is square root of 3/2. Cosine
Plus
of alpha,
1/2.
right. -3 over cosine of alpha is -3/5
Over 5 times 1/2.
times 1/2. Good use of. Okay. And now, just doing the algebra now, right? 4 square root of 3/10. And then minus 3/10. And go ahead and put them both under the same denominator. And we have one last problem, and we'll call it there. Everybody good with this one? Yes, no, maybe so?
Yes.
Okay, so last problem is tangent. So this is the tangent formula, right? So the tangent of alpha plus beta is equal to, it says the tangent of the first angle. So that would be tangent of alpha plus the tangent of the second angle, which is beta, divided by 1 minus their product. So it should be what?
1 minus tangent of alpha times tangent of beta.
Yeah, 1 minus tangent of alpha times tangent of beta. So go ahead and write down the formula in case you don't have it in your notes already. And then we're going to apply it. Okay, It says verify the identity. Tangent of the quantity x plus pi is equal to tangent of x. The more challenging one is the one on the
Left.
left. Good, Jasenia. So we're going to work with the one on the left. Whatever's more challenging, that's the one we're going to work with and try to get to the one on the right. So we have the tangent of x plus pi, right? Well, we just talked about the formula, right? Tangent of alpha plus beta is what? Tangent of alpha, go ahead,
Plus tangent of beta.
plus tangent of beta over
1 minus
1 minus,
tangent of alpha times tangent of beta.
very good, tangent of alpha times tangent of beta. So I'm applying the same thing to x and pi, right? So it should be what? My numerator would be what?
1.
Well, look at the formula and look at what you have there. Alpha is what value? Alpha is
X.
x and beta is?
Pi.
Pi.
So rewrite it first, right? So it would be what? Tangent of
X plus
X.
tangent of pi.
plus tangent of pi over?
1 minus tangent of x times tangent of pi.
Good job. Got the idea? The reason we do this is because then it'll start to clear up some things. So the big question here is tangent of x. There's nothing I can do with that, but I can do something with tangent of pi, right? I can do something with that tangent of pi. So what can I do with that tangent of pi? If you recall, the graph of pi, or what, if you remember the tangent, we say it's sine over cosine. You can go that route, but I think of the graph. It just, to mind, always the graph comes to mind. And tangent of pi, right? This is the graph of tangent of x, right? And at pi, what's the value for a tangent?
Tangent.
And again, if you do sine over cosine, that'll work too. Okay, just to let you know, because some of you are going, I have no idea what this is, Delgado. I don't know what you're trying to get at. What's that value there? At pi, what is tangent? What are the coordinates of that point right there? They are what? Pi, comma, what?
0.
0. So tangent of pi is
0.
0. Right? Tangent of pi is 0. All day, every day, for the rest of time. Good, Roberto. Okay? So the tangent of pi is 0. So that means those two, right, can be replaced with what?
0.
0. Very good. They can be replaced with zeros, right? And when I replace them with 0, if I'm adding 0 in the numerator to anything, it's just going to be whatever it is, right? It's already tangent of x, right? And that when I multiply 0 by anything, that part becomes a 5 times 0 is
0.
7 times 0 is
0.
tangent of x times 0 is
0.
0. So that's going to go away. That's going to become a 0, right? So now that becomes tangent of x over 1. And then all I have to do is simplify, right? I simplify that, I get tangent of x. Look complicated, but you go one step at a time. Some of these are going to look simple, and then you start working on them, and they're going to look very ugly for a little while, and then they're going to get simple again because things start to drop out. But it's about how much you know. You need to know a lot for some of these. And it all goes back to understanding what you know about the unit circle and your tangent functions, your trig functions. Got the idea? So this identity is verified. All righty. We are good here. Any other questions? This is our last problem. This was it.
No.
No, we're good?
Yeah.
Yeah.
All righty. So let me pause the recording here. Don't leave yet. Let me take a picture of those of you who are still here. I had a few people leave because they had another Zoom meeting.